Okay, welcome back, and today we're going to start talking about power series. So we're going to start with the definition of power series, and then I'm going to show you some examples of these types of power series, ones that you've seen before. And then we're going to start later on getting into functions and how can we describe a function using power series. Okay, but let's start with the definition and go from there. So the definition of power series, there's basically two different ways of, well, not two different ways, but two different definitions depending on the center. Okay, so a series of the form where we have the coefficients, which are c sub n, and then we have x to the nth power. Okay, anything of this form is called a power series. Okay, and those are the coefficients. C of n are constants. Okay, and x is the variable, right? So anything of this form is called a power series, and we use the term centered at x equals 0. So it's centered at 0. Okay, now a series of this form, notice again we have the constants, c sub n, these are the coefficients, and then we have these where the variable is x, and we have another constant, a real number a. We would say that this is also a power series, but this one is centered at x equals a. Okay, so we would say it's centered at a. Okay, this is going to, we'll look at this a little more closely later on. Okay, now, we can have different power series, like for example, we can have a power series like this. Of x to the n. Okay? And this just gives us the geometric series, right? This is a geometric series where r, right, x is equal to r, right, the absolute value of r is less than or equal to 1 versus greater than, or excuse me, less than 1 versus greater than or equal to 1. So in this case, so this becomes a either a convergent or divergent series depending on what x is. Okay? So this is, again, this is an example of a power series. Also, we could have something like this. Okay, now again, we define 0 factorial as 1, and any value x to the 0 is also 1. Okay, we also define x minus a to the 0 power as 1, right? Even when x equals 0 and x equals a. Okay, let's see what else. So there's 1, so that represents a power series centered at 0. Okay, what's another power series? Well, another power series is this one. Right, that's also a power series. It's just that the coefficients are defined by n factorial. In the last one, the coefficients were defined by 1 over n factorial. Okay, so we can have the coefficients be represented by some nth term, right? So we have that. And then of course we can have something like this. So this is also a power series centered at 0. Or we could have something like this. Okay. So this is also a power series, centered at x equals 2, right? Excuse me. So now, to better see this, let's rewrite this. So now, what part is part of the power series? It's going to be, oh, hold on a second. Oh, I think I did not write this right. Put an N when this is x. So again, the part that has the x in it, so we can write this as 1 over the quantity n minus 1 times 3 to the n, and then times x minus 2 to the nth power. And so you'll see that this piece right here is our c sub n, right? And so this piece here is our power part, and then of course we have our x minus 2 to the nth power, so we see that it's centered at 2. Okay, so again, just a few examples. So that's it. We'll continue on next time.